Okay, guys, let us solve the fourth problem. This is the circuit. So this is the circuit. These are the branches. So we are asked to find the V naught, I naught, and V naught. We are asked to find I naught and V naught. Simply to calculate this, so V naught is simply the current on this branch is not given. The current on this branch is simply 9 amp, which is the source, the current source, whereas this one is given by I naught. The current on this branch is a dependent current source, which is I naught over 4. I naught over 4 is given. On this one, it's not given. So we know that from Ohm's law, the voltage on parallel branches are equal. When they are parallel, the voltage on those parallel branches are equal. The voltage on this one is V naught. So all the voltage on all branches are, so these four branches share two nodes. Like this can be combined into one, this also can be combined into one. So the voltage on each branch is V naught. So V naught is equal to I naught times 2. The voltage on this branch is 2 times I naught. So we can express V naught as I naught times 2. I naught times 2. So to express the voltage in terms of the current, so we can assume this as equation 1. So we are asked to find I naught and V naught. So their relation. So as an equation to solve the problem, we can we have to make an equation which relates the two variables. So also applying KVL, Kirchhoff's voltage law. Kirchhoff's voltage law, we know if these are perfectly parallel, so we can combine them. We can assume them as a closed system and combine them as a current sources. Just adding them is the combination of this source can be assumed into 0. So the current on each branch can be combined into 0. The summation is 0 from KVL. From, as you see, this the combination of these sources, if they are closed, they can be assumed into 0 from KVL, like this one. So one of the application of KVL is combining current sources, or a current in a branch can be combined into 9 ampere I naught over 4. So 9 ampere minus I naught over 4. The current on this branch is simply V naught over 8 ohm, because the current on this branch is simply, because the voltage divided by the resistor give us the current on that branch, because it is the only element on this branch. So the current will be the voltage across that branch divided by the current. So the current on this branch is given by V naught over 8. So from KVL, combining this is equal to 0. This is one of the application of KVL, combining current sources which are in parallel, or currents on a branch which are perfectly parallel, So 9 minus I naught, rearranging simply these terms, 9 minus I naught over 4 over so I naught over 4. This is because we know that we can substitute this in place of V naught. We can substitute this. So in order to just to move out this element to calculate I naught, so we substitute I naught times 2 in place of V naught. So substitute this equation into this equation. So 9 minus I naught over 4 minus I naught 2 times 2 is cancelled by 8, just I naught over 4, which is equal to 0. So rearranging these terms, I naught will be 6. I naught is 6 ampere. So combining this, minus 3 over 2, I naught is 6 ampere. So V naught is I naught times 2. So 6 times 2, which is 12 volt. Which is 12 volt. This all. Thank you for your attention.